Let's do another example. Find x-intercepts of fx equals to x times root under x plus 5 and apply Rolles theorem to find out c between those x-intercepts such that f prime of c equals to 0. So again the similar idea. So what is given? F of x, let me use different color. So f of x is given as x and then root under x plus 5, right? How do you find out the x-intercept? To find out the x-intercept, we said y equals to 0, right? So we do, this implies 0 equals to x root under x plus 5. So you solve x equals to 0 and x plus 5 equals to 0. What are the x-intercepts? X-intercepts are x equals to 0 and negative 5. So you want to use the Rolles theorem in the interval negative 5 and 0. You see that? This is the interval. What it says is apply Rolles theorem to find out c between those two x-intercepts. So we are applying the Rolles theorem in this interval, okay? So to apply the Rolles theorem, what we do? We check the three conditions. You see that? So we check the three conditions. So let us check that. So first condition is the function fx is continuous? Continuous on the interval negative 5, 0? The answer is yes, right? Why? Because there is no x in the denominator. So the function is defined everywhere, right? So the function is defined everywhere that gives you value or positive value under the root. So looks like the domain is negative 5 through infinity, right? Because if x is negative 6, negative 7 like that, you will get negative number under the root. So negative 5 through infinity is the domain. So the function is continuous. If you draw the graph of this function, you will see that the function is continuous right to negative 5, including negative 5 and right, okay? That's how the domain look like. Domain is like negative 5 is here and everything right of that is the domain. So the function is continuous. Is the function differentiable? We will check that, okay? Let's find out the derivative. So so the answer for this is yes, right? Let's find out f prime. How do you find out f prime? You think that this is like f times g. You will find out the derivative by product rule, right? So so what is the product rule? It is f prime times g. F prime is 1 times root under x plus 5 plus f times g prime. What is the derivative of root under x plus 5? It's like x plus 5 to the 1/2, right? This is like a u. So u to the 1/2. So it will be, how do you write the derivative of that? It will be 1/2 u is x plus 5 to the 1/2 minus 1 times the derivative of u. Derivative of x plus 5 is just 1. So if you simplify that, you will get root under x plus 5, okay? And then plus x over 2 root under x plus 5. This is what you will get. You see that? So because when you simplify this, you will get x plus 5 to the 1/2 minus 1 will be negative 1/2. Since it will have a negative exponent, I'll move this to the denominator, right? So what is left is x is left on the top, and in the bottom there will be 2 times root under x plus 5. Now there is 1 in the denominator, right? How do I combine these two? So you will get like this. You will get basically 2x plus 5 root under, right? And then you so it is just like a cross multiplication. You see that? So it will be x root x plus 5 times 2 root x plus 5 will be 2, and then x plus 5, and then plus x times 1 is just x, right? What do you get? 2x plus 10, right? So you will get 2x plus 10, and then plus x will be 3x plus. So you will get 3x plus 10 divided by. So basically you will get f prime of x equals to 3x plus 10 divided by 2 root under x plus 5. Is this differentiable in the open interval? Yes, because at negative 5 it does not exist, but anything right to negative 5 exists. So but we will be looking only in the interval. What interval you will be looking? The open interval. You will be looking at the interval. So you can write f is differentiable in the open interval -5, 0. That's the Rolles theorem second statement. How about the third statement of the Rolles theorem? You need fa equals to fb. What is f of -5? If you plug in f at x equals -5 here, you will get -5 times -5 plus 5 is 0, right? 0. And how about f at 0? F at 0 is also 0. So it applies the Rolles theorem. So we can apply the Rolles theorem because it satisfies all the conditions. So by Rolles theorem, you get f prime is equals to 0, right? You will get a point where the derivative is 0. So if you do that, you will do the numerator of that equals to 0, right? So what you get is that implies 3x plus 10 equals to 0. Because when you set, let me show you that. If you set that equals to 0, that thing equals to 0, then you multiply both sides by that 2 root under x plus 5. If you do that, that will cancel with 2 root under x plus 5 and then times 2 root under x plus 5, right? So that will cancel out. So what you will get is 3x plus 10 equals to 0. That's what you will get. That's what I got here. If you subtract 10, let's subtract 10. Subtract 10, you will get 3x equals to -10. So what is x? You divide by 3. You will get x equals to -10/3. So that is basically c value, okay? So c is -10/3. You got. So this is the point that c equals -10/3 lies between -5 and 0 as well, right? So this is the value that we were looking for. Let us do one more example here. Determine if the Rolles theorem can be applied for fx equals to that on the interval -1, 3. Okay. So how do I do that again? So you need to check all those three things, right? So number one is if is fx continuous on -1, 3. What do you think? Fx is continuous everywhere except at -2, right? Because see, at -2 this will be basically 0, right? So something over 0 will be infinity. So it is not continuous at that point, but everywhere else this will be continuous. So the answer is yes. We are looking between -1 and 3. -2 lies outside that, so we don't have to worry. So we are looking only in that interval, so it is continuous. How about the differentiable? Let's find out f prime to check the differentiability. So this is like f over g. You see that f over g. What is the formula for the derivative of the biquotient rule? What do you think? It is f prime is 2x minus 2, right? The derivative of the top times g is x plus 2 minus f is x square minus 2x minus 3. Okay, and then x square minus 2x minus 3 divided by x plus 2 square. Why did I miss that g prime? Because f prime g prime is 1, right? Because the derivative of x plus 2 is 1, so I didn't write that one. So if I simplify, what do I get? I need to FOIL this one. So what do you get here? It is 2x times x is 2x square plus 4x minus 2x will be plus 2x minus 4, and there will be negative x square plus 2x plus 3 over x plus 2 square. You see that? Now if you simplify, what do you get? 2x square minus x square is x square, right? And then plus 2x is plus 4x minus -4 plus 3 is -1. This is what I get over x plus 2 square. So is this function differentiable? I mean, if the derivative exists, yes, the derivative exists everywhere in this interval except, but this derivative does not exist at x equals -2, and x equals -2 lies outside this interval. So f is differentiable on the open interval -1 and 3. We don't even worry about the closed interval. We just look at the open interval. Also, tell me whether fa equals to fb. What is fa? Fa will be f at -1. What do you get f at -1? Let me plug in -1 for x here. -1 square is +1 minus 2 times negative 1 will be positive 2, right? Because 1 plus 2 is 3 and then minus 3 is 0 divided by negative 1 plus 2 is positive 1. So 0 over 1 is 0. F at negative 1 is 0. And F at 3, let me plug in 3 here. 3 square is 9. Minus 2 times 3 is 6. 9 minus 6 is 3. Minus 3 is 0 over 3 plus 2 is 5. 0 over 5 is also 0.